Hi everyone. In this lecture we will study these three type of shift register: bidirectional shift register, universal shift register, and left linear feedback shift register. Okay. So first we will start with bidirectional shift register. So what is a bidirectional shift register? The name itself is telling you. Okay. So the unidirectional we have already seen actually. The unidirectional shift right register we have already seen, correct? So this we have already seen, shift right register. Okay, so in this unidirectional, because this is the shift register we have already seen. Unidirectional means only in single direction. Okay, so that is right direction. So this register we have already seen where you have, okay, so these are your flip flop and this is your clock, and all the flip flop they share the common clock. So this is your, okay, these are the flip flop, and you can notice this is a shift right register. So what we do, we connect like this. Okay, the output of this first flip flop is connected to the input of second flip flop. Okay, and you can notice the output of the output of the second flip flop is connected to the input of the third flip flop. Okay, so this you can notice this register. If you notice this shift register, this is shift right register because we can shift in the direction, in the right direction. Okay, so if you have this data, okay, this 1000, if the, okay, let us assume that this register is a shift right register. Okay, so what it means, that it means that in the next clock pulse, okay, in the next clock pulse, okay, if these flip flop are positive edge triggered, then basically after one positive edge, okay, after one positive edge, what will happen? So this data will shift to the right. Okay, so this is going to happen. Okay, so you can notice this will be 0 1, and this new data we can insert. Okay, so this new data we can insert, and this data will be lost. Okay, so this is your unidirectional shift right register. Why unidirectional? Because this can only shift in the direction of right. Okay, in the right direction it can shift. Okay, so you can notice the only direction in which we can shift is right direction. So that is the reason this is unidirectional shift right register. Okay, what is unidirectional shift left register? Okay, if I want to create unidirectional shift left register, basically this type of register I want, that okay, if this is my data 100, then what should happen? I want this type of okay, what I want shift left register. Means what should happen after one clock pulse, after one positive edge. Let us assume that my I can say after let us assume that my flip flop are positive edge triggered. Then basically I can say that after one positive edge, what should happen? The data should shift in the left direction. Okay, so this data should shift in the left direction. Means okay, this is the new data that we are inserting. So this is what we want. Okay, after one clock pulse, after one positive edge, this is what we want. Okay, so this type of register, this is called unidirectional shift left register, because in this type of register we can only shift in one direction, that is left. In the left direction we can shift. Okay, now how to create this unidirectional shift left register? So the idea is very simple. The idea is similar to shift right register. How do we create shift right register? Similarly, you can create shift left register. So you can notice that how do you create shift right register? If you want to create shift right, if you want to create shift right register, then how to do that? Okay, so same method, the same idea we will apply on the shift left register. Okay, so in the shift right register, what we do? Okay, you can notice the output of the first flip flop is connected to the input of the second flip flop. The output of the second flip flop is connected to the input of the third flip flop, and the output of the third flip flop is connected to the input of the fourth flip flop, like this. Okay, so this is the idea. You can notice. Okay, this is the idea of shift right register. Okay, so this output I can say, okay, so this output is connected to this input, and this output is connected to this input, and this output is connected to this input. Okay, so this is the idea. Now if you want to shift left, then what you need? Then basically you need like this. What you need? Okay, so these are your flip flop. Let us assume you have three flip flop. Okay, so in this situation, you what you need? D1 Q1, okay, D2 Q2, okay, D3 Q3, and let us assume you have one more. Okay, so let's assume that you have one more, that is maybe, okay, D0 Q0. Okay, so let's assume this is your, now you have these four flip flops. Okay, now what we want? We want shift left, shift left. Okay, and so if you want shift left, then where to insert this data? So this data must be inserted here. Okay, so this data we want to insert here. And what we want shift left. Shift left, what it means actually? Okay, if you notice, then this is what we want. Okay, so this is your, I can say this is q0, this is q1, this is q2, this is q3. So what we want to do, the output of this the output of this should be connected to the input of this. So I can say this output must be connected to, okay, you if you focus here, so you cannot, this output must be connected to this input, correct? And similarly this output must be connected to this input, and similarly this output must be connected to this input. Okay, so this type of situation will give you shift left register. Okay, so you can notice shift left register. If you want shift left register, then this type, so this is your shift right register. Okay, you can notice. Okay, so this is your shift right register. This situation will give you shift right register. Okay, so this is your input. Okay, so this is your shift right. So this register is your shift right. And if you want shift left register, okay, if you want shift left register, then this situation will give you shift left register. What you need to do? Okay, so this is what you need to do. You need to connect this output to this input. Okay, and also what you need to do, you need to connect, okay, you need to connect this output to this input. Okay, and what else you need to do? You need to connect this output to this input. Okay, so this is what you need to do. Okay, so this will give you shift left. And the new input that you want to insert, you can insert in this rightmost. Okay, so this is the idea. Okay, I hope the idea is clear to everyone. Okay, so you can notice unidirectional shift right. So because in this register we can only do the right shift, in this register we can only do in this sorry in this register we can only do shift left. Okay, now what we want to study, we want to study bidirectional shift register. What it means? It means that it is in our control. Okay, we will control whether we want to do right shift or left shift. So this should be in our control. Okay, so what I'm saying, this bidirectional, okay, this bidirectional shift register, in this what we want to control basically. Okay, we want to control whether you want to do the left shift or right shift. Okay, so based on, there is a control input, based on that control input, either you can do right shift or you can do left shift. Okay, so again what you will use, okay, from the previous lectures you can notice one thing, that okay, in this type of situation, when you need to control something, when you need to give more than one functionality, here what we want, we want two functionality. Okay, we want two functionality, that is, okay, if we want to shift right, then we should be able to do shift right. If we want to do shift left, then we should be able to do shift left. Basically we want to control, okay, whether to do shift left or shift right. Okay, so for that what we will do, we will use a control input. We will use this control input lr bar. Okay, what is lr bar? Okay, lr bar is very simple. If lr bar is 0, then what you do, then you do right shift. If this is 0, then what you do, then you do right shift. And if this input is 1, then what you do, then you do left shift. Okay, so this input will control, using this input we can control whether we want to do right shift or left shift. Okay, so the idea is very simple. Okay, now you can just implement this idea. So how will you implement? Very simple. So okay, let's create only three, let's assume 3-bit, let's create this 3-bit register again. Okay, so there is a clock. Okay, so the same common clock is basically applicable on all the flip-flops. In the register I told you that every flip-flop share the same, okay, common clock. Okay, and anyway, so this is your d1 q1, this is your d2 q2, this is your d3 q3. Now what we want, so there is a, okay, so what we will do, okay, so if this input is 0, then we will do right shift. Okay, so we will do right shift when this input is 0. So again what we will do, we will connect this multiplexer, we will connect. Okay, so this is your multiplexer. Okay, and now what we want to do, so you can notice that when this input is 0, okay, so this input we have. Okay, and what you can notice, okay, so here, okay, so let's connect one multiplexer here also. Okay, so this input we have. Okay, so what is this input? So you can notice, so this is your input, L R bar. This is your input L R bar. Okay, now you can notice that when this input, when this input is 1, then what we want to do left shift, and when this input is 0, then we want to do right shift. So when this is 0, then we want right shift. Okay, when this is 0, then we want right shift. So okay, if this is 0, then what we want to do, then this is what we want. Okay, if you put this 0, then what we want, we basically want, okay, this is what we want. So we want to do right shift. Okay, so you can notice here, you can notice here, when this is 0, when this LR bar is 0, then what will happen, then this 0, this 0, this 0. Okay, so you can notice that this input will go to the output. Okay, this input will go to the output. Okay, so like this, it will happen. Okay, like this it is going to happen. Okay, correct. So this is the idea. Okay, so if this is 1, then what will happen, then I can say that, okay, so this I can connect like this. Okay, so what I can do here, here you can connect like this. Okay, and okay, so this 0 you can connect with in, okay, input. Okay, now so when this is 0, then this is fine. Now when this is 1, then we want left shift. Okay, when this is 1, then what we want, when this signal is 1, then we want left shift. Left shift means, okay, this output is connected to D2. Okay, so means I should connect Q3 here, I should connect Q3 here, because remember this must be connected to D2. So what should I do, I should connect Q3 here. Similarly, this I should connect to D1. Okay, so what should I do, I should connect Q2 here, I should connect Q2 here. Correct. Okay, so this is what I want, and what I want, I should connect this in here. Okay, so this you can notice. Finally, now from this diagram you can very easily notice what will happen. Okay, you can notice that when this is 0, just assume that this is 0. If this is 0, then what will happen, if this is 0, then this is going to happen that, okay, so this input will be going to D. Okay, so you can notice in this situation this will happen. Okay, in this situation this input will go to D1. Okay, and this Q1 will go to Q2. Okay, so you can notice this Q1 will go to D2. Okay, and this Q2 is connected to D3. Okay, so you can notice when this is 0, when this is 0, so you can notice, so okay, so L R bar 0. Okay, that implies, what that implies, that implies shift right. Okay, so this implies shift right. And similarly you can notice when this is equal to 1. Okay, when this is equal to 1, then what will happen, then this Q2 is connected to D1. Okay, and you can notice this Q3 is connected to D2, and this in is connected to D3. Okay, so in this situation you can notice that if L R bar is equal to 1, then it means this is a shift left. Okay, so this is how you can create bi-directional shift register. Okay, I hope this concept is clear to everyone. Okay, so this is how you can create bi-directional shift register. This is your 4-bit bi-directional shift register, the same idea. Okay, again you have the, okay, so using the multiplexers we are doing this. Okay, so you can notice when this is 0, okay, then it means we want left right shift. So when this is 0, then you can notice this is connected to D1. Okay, and this Q1 is connected to D2, and you can notice this Q2 is connected to D3, and you can notice this Q3 is connected to D4. Okay, so it's very simple that, okay, when you have, when this LR bar, when this is equal to 0, then this is right shift, and when this LR bar is equal to 1, then this is basically left shift. Okay, so this is your bi-directional shift register. Okay, so this is your 4-bit bi-directional shift register. Okay, now the next concept that we will see, the next shift register that we will see is universal shift register. Okay, what is this? Okay, the name itself is telling you universal shift register. Basically, all the functionality that you have seen so far, okay, all these functionalities you put in one single register. Okay, so basically a single register has all the functionality that you have seen so far. So what is a universal shift register? In a universal shift register, you have clear input. If you want to clear the register, if you want to clear the register to 0, then you have clear input. You have a clock, okay, which is applicable on to all the flip flop. Okay, and similarly you have shift right, you have shift left, you have parallel loading. Okay, and you have basically parallel output, and you have, okay, okay, so basically these, all these functionality that we have seen so far, all these functionality we want. So what is a universal shift register? Let me tell you. Universal shift register In this universal shift register, all the functionality we want, basically we want a register, this type of register we want in this register. If you want, you should be able to do, okay, if you want to insert the data in parallel, you should be able to do this. If you want to read the data in parallel, you should be able to do this. So basically in this we want PIPO functionality. Okay, we also want, if you want to insert the data in serial manner, if you want to read the data in serial manner, so we want SISO functionality also. Okay, we also want, if you want to do right shift or you want to do left shift, so we want right shift also. Okay, so basically we want bi-directional. Okay, what we want bi-directional. Okay, so this is also what we want. So this is what we want. Okay, bi-directional. Okay, so we want this functionality PIPO, we want SISO this functionality, also we want this bi-directional functionality. Okay, and also we want something called no change. Okay, like if you just want to store, if you just want to store storage, or I can say retain. Okay, storage, or I can say data retain. If you don't want to change, you don't want to shift, you don't want to insert, okay, you don't want to insert the data, you don't want to shift the data, you don't want right shift, you don't want left shift, basically. Okay, all these functionalities must be there. We should be able to control it. Okay, if we want, we can have this. If we want, we can have this. If we want, we can have left shift. If we want, we can have right shift. This type of register is called universal shift register. Okay, and how do we do that? Okay, how do we do that? So again, here we have so many functionalities. So what we need a 4 by 1 mux. Here actually we need 4 by 1 mux. Okay, so what we can use 4 by 1 mux. I can say that we can use 4 by 1 multiplexer. Okay, okay, in this 4 by 1 multiplexer, what I'm saying that we can use s1 s0. Okay, when these are 0 0, then basically, okay, this is the action. Okay, so you can notice when these are 0 0, then we just want the data to store. Storage means basically the data should be retained, the data should be retained, and the data should not change. Okay, so the data should be retained. Okay, and if this is 0 1, then let's assume that we want left shift. Okay, so 0 1, then let's assume we want shift right. Okay, so means when this is 0 1, then we want shift right, and when this is 1 0, then we want shift left, and when this is, then we want basically PIPO. Okay, so this is the point. Okay, I hope this point is clear to everyone. So you can notice what I'm saying that universal shift register. So the name is telling you what it means. It means that it is universal, means all the functionality that you have seen so far, all these functionalities are present here, and we should be able to control it. Okay, so for example, we should be able, okay, if you want this functionality, you should able, okay, if you want this, or whether you want left shift or right shift, all these things are present, and you must have something that will control it. So we need to control input. Basically we can, what we can do, okay, so 4 by 1 mux we can use, and using these we can control. So two control input we need. Okay, so these are your control inputs. These are your control inputs. Using two control inputs, you can control what functionality you want. Okay, if you want shift right functionality, then what you can do, you can put s1 equal to 0, s0 is equal to 1. If you want shift left functionality, then you can put s1 equal to 1, s0 equal to 0. Okay, so now what we can do, we can create a universal shift register. Okay, and finally this is your universal shift register. This is 3-bit universal shift register. Okay, and you can analyze this. Okay, let's analyze this one by one. So let's analyze what will happen when you have 0 0. Okay, so 0 0 means when s0 is 0, okay, s1 is 0. In this situation, what should happen? In this situation means when both are 0 0. Okay, so let's assume both are 0 0. Okay, so here when I can say, okay, so let me just write here. Okay, so let me just write here, if s1 equal to 0. Okay, if both are 0, then what should happen? Then basically this is a data storage, then nothing should happen. Then this should be a data storage, means there should be no change. I can say there should be no change. Okay, data should be retained. Data should be retained. Now let us see whether it is happening or not. When both are 0 0, this is 0 0, this is 0 0, when all are 0 0, then what will happen? Okay, when these all are 0 0, then what will happen? In this situation you can notice, okay, okay, so you can I can say that, okay, so let's assume this is 0 1 2 3, and let's assume this is 0 1 2 3, and let's assume this is 0 1 2 3. So you can notice if both are 0, then what will happen? You can notice that q1 is connected here, means the present output will be your next output. Okay, so you can notice the present output will be your next output. Similarly here also q2 means present output will be your next output. Here q3 means present output will be your next output. Okay, so you can very easily see that when s1 equal to 0, s0 equal to 0, when both are 0, then in that case basically we are get nothing is changing. Okay, the register will retain its data. The register will retain its data. Okay, retain its data. The register will retain its data. Similarly you can notice what will happen when, okay, when s0 equal to 1, as when both are 1. Okay, then in this situation what will happen? In this situation what will happen? In this situation, so you can notice when both are 1. Okay, when both are 1, then what should happen? You can notice from this table, then what should happen? Then this parallel load should happen. Okay, in this situation, then I can say that parallel loading, I can say, okay, PIPO. Okay, so in this situation you can notice when both are 1, then what will happen? You can notice that this d1, okay, so this new data you can notice. Okay, because when both are 1, here also when both are 1, here also when both are 1, then you can notice this new data will be inserted. Okay, this new data will be inserted, and we can read this data. Okay, very easily we can read this data. If you want to read, you can read this data like this. Okay, so quite simple. So this is your universal shift register. Remember, in gate exam they will not ask you to create a universal shift register, but they can give you some register and they will ask you what is the functionality. Okay, what this register is doing. So they can ask you this type of questions. Okay, what is the functionality of a register, what a register is doing. Okay, so this type of questions they can ask you. Okay, so this is your bidirectional shift register and universal shift register. In the next lecture, we will see linear feedback shift register. Okay, so this is another very popular type of shift register. Okay, and we will also see some gate exam questions which are based on this linear feedback shift register. Okay.